Welcome everyone to the Valleywise Central Utility Plant at the Roosevelt campus. My name is Jimmy Kern. I'm a project manager for Kitchell Contractors over the Central Utility Plant and Site Utilities scope of Phase 1.
The Central Utility Plant ultimately is the infrastructure backbone for the campus as a whole.
By the end of October, the new central plant was powering the entire Valleywise campus here at Roosevelt.
Most unique perspective of this particular phase is the fact that we essentially built a building within a building.
Some of the other unique aspects of it is just the size of everything. We have 5 1,500-ton chillers, 3 2.5 megawatt generators, huge pipe for the chilled water side. Trying to squeeze it all into the building. This building wasn't necessarily made for a central utility plant.
This building is a concrete tilt panel structure. Its sole purpose in life before we showed up was supply chain warehouse for the entire campus. The design team, somebody came up with a crazy idea to now build a standalone structure within the building while it's still functional as a warehouse, and ultimately put a central utility plant within that structure that we assembled.
There's so many different buildings spread out through this campus that if you were to put the central plant in one corner, you still have the challenge of getting pipe and power all the way across campus to the 2619 building. And if you put it, in another corner, then you have to go all the way up to the new tower. So really, its location, I think, was the main driver.
So the locating of the underground utilities process, it was pretty involved. So we spent quite a bit of time up front before we even had contractors on board and on site to go out there with our BIM team, as well as potholing contractors, utility locating contractors, and we literally mapped out just about every single utility that's known on this campus. From 24th Street to the east and Roosevelt to the south, lots and lots of utilities, lots of unknown utilities that we came across naturally. But at the end of the day, the client has a really comprehensive and accurate as-built model, which is great for their use. But lots of coordination. The BIM team was super involved with that whole effort, and ultimately allowed us to excavate in a safe manner and really minimize any utility strikes throughout the utility install process. It's a functioning campus. Their kind of day-to-day operation comes first. So everything we did, we had to plan around that. Access to and from one side of the campus to the other is pretty much limited to a single street pierce. And unfortunately, that's where a majority of our work needed to take place. So lots and lots of coordination with our contractors to say, how can we chop this up into manageable chunks and still be safe and productive, but then also keeping traffic flows, both vehicular and pedestrian, in place. So lots of upfront coordination. Then we would sit in meetings with pretty much a representative from each user group across the hospital and talk about, this is how we'd like to do it, get each of their concerns, and then go back to the drawing board, tweak our plan, come back and meet on it again, and then ultimately implement that coordinated plan with the team as a whole.
This project is set up for a big room. Our owner's representative is in our trailer, so that has helped us, especially through COVID and everything else, really on the coordination front. Anything that we need to do on the campus obviously has to be ran through them, and it makes it extremely easy for us to be able to go over there and have a conversation with them to show them, get in one of our larger meeting rooms, and before at their desk or at our desk, kind of look at it and make the plan together and really help that coordination effort on the front end. This cup is designed N+1 obviously for the hospital, but I think it's actually a little bit more than that. So kind of like what I said earlier, we have 3 generators behind us, we have 5 chillers, and we have 10 boilers. So there's room for expansion in all these buildings, and the expansion would be 1 more generator, 1 more chiller, and 2 more boilers. And talking with AEI, the engineer and designer on the project, by adding those 2 boilers, 1 generator, 1 chiller, it would essentially support a whole nother tower. Now whether that happens in 30, 40 years, we'll see, but it would have the ability to power 2 towers.